Graphing rational functions. Graph the function y equals 4x minus 5 over x minus 2 and identify any asymptotes and intercepts. So for us to graph this one, there's a couple different strategies. Knowing the asymptotes and intercepts and even testing points could work if you needed to. I always like to convert it into a over x minus h plus k form. So that's what I'm going to do, because then I can make sure that I have got my a value clearly in there and I'm not missing any vertical stretches and key points. So we're going to divide. That's the method I prefer to convert it. And I'm going to do my synthetic division here, and doesn't take long to do the synthetic division. So you get 4 plus 3 over x minus 2. So my equation is y equals 3 over x minus 2 plus 4. So that means I do have a vertical stretch by a factor of 3. This means that it's going to go right 2, and this means it's going to go up 4. So let's put in our asymptotes. So right 2 would mean here. So in this form, you automatically know that your h value is going to tell you your horizontal asymptote. It's still the NPV. I could have known based on this. Your denominator doesn't change in either form, so your NPV is still your vertical asymptote. So I could have figured that out without converting it. Okay. Up 4, so my horizontal asymptote is up 4, so the k value tells you your horizontal asymptote. Now, another strategy would be to use the rules that we learned. If the degree in the numerator and the degree in the denominator are the same, then it's the leading coefficient of the numerator divided by the leading coefficient in the denominator. So 4 over 1 is 4. So we have a vertical asymptote at y equals 4. So since it's said to identify these, we want to clearly state that we have these. So I did not actually have to convert to this form, but the nice thing is these two match up in terms of asymptotes, so you know for sure you're on the right track. Now, I use then the a value to help guide this. So the a value is 3, so that means from the origin of the asymptotes, we'll say, we're going to count 3 and 1 up, and 1 over, and 3 up. And that's enough points. We don't have too big of a gap here. You just, as long as you have those 2 key points, you've got enough. Here we're going to go 3 and 3 this way. And we're going to go through, and we're going to make sure that intercept is correct on these as well. It's kind of hard to see. I'm going to make sure. So I would not be 100% sure what those intercepts are. I can tell they're fractions. Now, some people like to use the intercepts as find them first, which is a great idea too. The only thing in this graph is if you found the intercepts first, those are 2 points that you could have used, but it wouldn't help you here. So you want to make sure, that's why you need to find that a value, is you want those clear vertical stretches drawn in there. Okay, x-intercepts, you're going to let y equal 0. So we're going to put 0 in. I like to use the original function. You'll see that'll be a little more valuable to us later on as well. 0 times x minus 2 is 0. Your denominator disappears if you multiply that side. So I'm cross multiplying. Move the 5 over. So I get x is equal to 5 over 4, which is 1 1/4. So I'm going to take a look here. 1 1/4. Yeah, that can be 1 1/4. I could label that. I've got it here, so we'll just use this is our answer. Y-intercept, we're going to let x equal 0. So y is equal to 4 times 0 minus 5 over 0 minus 2. So y is equal to 5 over 2 now, which is 2.5. And if you take a look here, that's where I graphed here as well. But now I'm not estimating. I know exactly what those points are for the intercepts. And it said to clearly identify these two.